Reflection of waves. By the end of this lesson, you should be able to describe the reflection of waves in terms of the angle of incidence, angle of reflection, wavelength, frequency, speed and direction of propagation. Draw a diagram to show reflection of waves. What can you see at the surface of the water? The surface of the water shows the reflection of the moon. What happens to waves when they are reflected? When you let out a shout in a canyon, what do you hear? Echoes can be heard. How are echoes produced? A ripple tank is a shallow glass tank of water used to study the properties of water waves, namely reflection, refraction, interference, and diffraction. The ripple tank is usually illuminated from above, so that the light shines through the water. The ripples on the water show up as dark and bright regions on the screen underneath the tank. A plane dipper vibrates on the surface of the water. What do you see? Why? Plane waves are produced. A pattern of bright lines is observed on the screen below the ripple tank. A spherical dipper vibrates on the surface of the water. What do you see? Why? Circular waves are produced. A circular pattern of bright and dark regions is observed on the screen below the ripple tank. The dark and bright patterns are formed when rays of light pass through the troughs and crests of the water waves respectively. What can you say about the pattern and direction of the incident wave as it approaches the barrier? What happens to the waves as they reach the barrier? Upon reaching the barrier, the waves are reflected and head in a different direction. Observe the direction of the reflected wave. The waves will reflect at an angle such that the angle of incidence equals the angle of reflection. This is known as the law of reflection. What happens to the wavelength after reflection? The reflected waves do not change in wavelength, even though the direction changes. When frequency and wavelength are kept constant, what happens to the speed of the wave after reflection? The speed of the wave is related to frequency and wavelength, where speed is the product of frequency and wavelength. When the frequency and wavelength are kept constant, the speed also remains constant. Put a stop clock at one end of cylinder A and aim it at an angle to the wall. Cylinder B is also placed at an angle to the wall. At what position of cylinder B is the ticking of the stop clock the loudest? Rotate cylinder B to find that position. What can you say about the position of cylinder B when the sound is the loudest? The position of cylinder B is at the same angle to the normal as cylinder A. The angle of incidence, I, is equal to the angle of reflection, R. This is known as the law of reflection. Plane waves are moving towards a barrier at an angle. Determine the direction of the reflected waves. You can do so by following these steps. Firstly, draw a straight line to represent the direction of propagation of the incident wave. Make sure the line is perpendicular to the wave fronts. Then, draw the normal at the point where the line you drew earlier touches the barrier. The normal must be perpendicular to the barrier. Measure the angle of incidence, I. Now, draw a line representing the reflected waves from the same point, such that the angle of incident, R, is equal to the angle of reflection, I. Lastly, draw the wavefronts perpendicular to this line. Make sure that the wavelengths of the incident and reflected waves are the same.